We could do acceptance rejection from last lecture.
Right, we can do acceptance rejection method. And what do we start with from the acceptance rejection method? Like what kind of samples do we wish to reject or accept?
We start with a uniform distribution.
Between
then,
what and what?
Not sure.
Right, this triangular distribution we are looking at here starts with 210, peaks at 220, and finishes at 250. If we want to accept or reject using a uniform distribution, what kind of uniform distribution should we start with? Right, we want to start with a distribution that kind of covers the desired distribution. I mean, what do we mean by covers is that if I multiply the PDF by a finite multiple, the PDF is going to be higher or equal than the desired PDF, right? So in this case, what's the narrowest uniform distribution that encompasses this desired triangular distribution? Well, if you use the requirement that we know, right, we have to kind of cover this this triangular distribution, then it doesn't really matter. I mean, I can as long as I have a uniform distribution that starts below 210 and ends beyond 250, it's gonna work, right? But then I'm gonna be wasting a lot of samples because I actually have to reject everything below 210, and I also gonna be rejecting everything above 250, right? Because the ratio of the PDFs are going to be 0. The triangular distribution has 0 PDF there. So the narrowest, the most efficient uniform distribution to use is a uniform distribution between 210 and 250, right? Okay, so if we use that, then we're going to be sampling a bunch of uniform distributions between 210 and 250. The way to sample that is I have a bunch of uniform, basically rand and samples. That's a uniform distribution between 0 and 1, right? How do I modify it to make it uniform between 210 and 250? How do you do that? If I hist a delta V with 100 bins, rand and samples and 1. Make the same mistakes. Yeah, so I get a uniform distribution between 0 and 1. How do I make these uniformly distributed between 210 and 250? Well, if I add the entire array of delta V by 210, right, I get, if I run this again, I get a uniform distribution between 210 and 211. So I have shifted the entire samples to between 210 and 211. But like, so I achieved my lower end. I also want to achieve my higher end, which is 250. Right, so I want to multiply everything by 40 before I add it to 210. So now my distribution is between 220 and 250. Right? All right, so that's basically the distribution I start with. Then in order for me to accept or reject, I want to also sample, I also want to compute the ratio of the probabilities, right? So and the ratio actually the ratio of acceptance has to go from 0 to here. So 0 goes to 1 here and go back to 0 here. So that's what I'm going to be computing, the ratio of acceptance. So accept ratio is going to be something that depends on delta V. It's going to be the minimum of delta V minus the lower threshold and divided by 10. So that is going to be capturing the slope from 210 to 220, right? And I have another slope that is actually the other slope also goes from 0 to it's going to be delta V minus 250 divided by 40, but it's going to be a negative of that. So if I take the minimum of these two curves, that computes my acceptance ratio, right? It's going to be 0 at 210, it's going to be 1 at 220, and again, it's going to go back to 0 at 250. So after I compute this acceptance ratio, I'm going to be sampling another independent random variable. It's going to be rand and samples. Okay, and the delta V is equal to delta V. And I'm only going to select the conditions that y is greater than accept ratio. Now, if I compute the histogram, accept ratio, spelling. Oops, I think I must have made a mistake. It turns out it's almost like the opposite of what I wanted, right? So I want a distribution that starts 0, peaks at 220, and goes down. So something is wrong during my calculation here. Oh, okay. So here is actually should be divided by 30, not by 40, right? And another bug is that my acceptance criterion should be the sample to be less than the acceptance ratio, not greater than the acceptance ratio. So after I fix these two, I get a nice triangular distribution. So if I increase the number of samples to 1 million, it'll take a little bit longer, but the distribution looks even nicer than before. All right.